Hello and welcome. Let's solve another interesting question. All right. So this is a simple supported beam with three inclined load. All right. So here we are going to be drawing the shear force diagram, the bend moment diagram, and the axial diagram, axial load diagram. All right. So, but before we can draw this diagram, we are going to be calculating the reaction at the support, the shear force calculation, the bend moment calculation, and the axial load calculation. All right, so we are going to be resolving these forces into x and y direction. So for us to do that, let's trace this point downward. All right. All right. 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 All right. And last but not the least. Right. All right. All right, so that's it. So this is what we are going to have. Now we are going to name this one, this place y1. So if this place is y1, this place 2 is going to be y1, x1, x1. So this one is going to be y2, 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 s2, s2. This one is going to be y3, y3, s3, s3. All right. So we don't want to be wasting our time here. All right, so for us to get what y1 is here, we are going to be taking sine, right? So opposite over what? Hypotenuse, right? So this place is going to be our 90 degree, and 90 degree. All right. So, and if we do that, we are going to have this side to be equals to 1.5 sine 30. So 1.5 sine 30 is going to give us what? 0.75. So this place is going to give us 0.75. All right. So if this place is 0.75, this place too is going to be what? 0.75. So this is the arrow here. So we are tracing towards the arrow. So this, our angle is going to be moving towards this side. All right. So it shows that we are going to have 0.75 here, 0.75. All right. So, and then our s direction, we are going to be using cos, right? So it's going to be 1.5 cos 30. And 1.5 cos 30 is what? It's going to give us 3. So we are going to have 1.3 here. All right. So similarly with this, our y direction here is going to be 0.5 sine 45, which is going to give us what? 0.353. All right. So for the s direction here, we are going to have 0.5 cos 45, which is going to give us 0.353. All right. So, and similarly with this, so here we are going to have opposite hypotenuse. So here we are going to have 1 sine 45. So here is going to be 1 sine 45, which is what? 0.707. 0.707. All right, this same thing is going to be 0.707. All right. So here we are going to have 0.707. All right. So but our arrow here is at this side. So we are coming to this side. So our s is moving towards this side. All right. So here this arrow here is coming towards this side. So towards this side. All right. So that is what we have. All right. So now we can start with our reaction at A and the reaction at B. All right. So let's move on. So we can therefore start with the summation of force in our y direction to be equals to what? 0. So here we'll be taking upward force positive, downward force negative. All right. So sum of upward force is going to be equals to sum of downward force. ROB will be equals to, so our our downward forces are what? 1, 2, and what? 3. And don't forget, this side is equals to this side. This side is equals to this side. So it's going to be equals to 0.75 plus what? Plus 0.353 plus what? Plus 0.705. So if we sum down together, we are going to have arrow subscript A plus arrow subscript B to be equals to key moment about point A. So if you sum all of these together, you are going to have 1.81. So moment about point A will be equals to what? 0. So if we stand at point A, we are taking moment towards this direction. So we are still using upward force positive, downward force negative. So ROB multiplied by the total distance. ROB multiplied by total distance is this is 3, 4, 5, 6. So multiply by 6 to be equals to, so here we are having a downward force. It's going to be 0.75 multiplied by what? 4 plus, so here we are going to have 0.33, 0.353 multiplied by what? Multiplied by 2.5. Multiplied by 2.5 plus 0.70 multiplied by 1, which is what? 0.707. All right. So this is going to give us what? 6 ROB, which will be equals to, so 0.75 multiplied by 4 and plus 0.3. If you sum all of this together, you are going to have 4.59. So that's what we are going to have. So we are going to divide both sides by 6. So if we divide both sides by 6, our arrows B, at this reaction at B, will be equals to what? 0.765, and this is going to be in what? Kilonewton. All right, so our arrow A now will be equals to what? Because we know from equation 1, we have arrow A plus arrow B to be equals to 1.81. So if we subtract 1.81 from arrow B, we get arrow A. So 1.81 minus 0.765, we get what? 5 kilonewton. All right. So now, the next thing now is to calculate our shear force calculation. So we are going to go for our shear force. Shear force calculation. All right. So we are going to start the shear force at point what? Point B. All right. If we start at point B to the right, point B to the right, the only force we have here is ROB, which is upward. So which is going to be positive, 0.765. All right, so the next one is shear force at point what? At point C. So we start at point C, we are going to have two forces, an upward force here and a downward force. So it's going to be 0.765 minus our downward force, that is 1.3. Sorry, minus 0.75. All right, so if we subtract this from that, what do we have? 0.015. All right, so this is going to be in what? Kilonewton. This is going to be in kilonewton. All right, so the shear force at point D now, shear force at point D will be equals to, so since we know the shear force at point C to be 0.015. All right, so the only thing we just need to do here is to subtract the shear force at point D from that of point C. So we're going to have this one minus 0.353. So if we do this, what do we have? Minus 0. What? 338 kilonewton. All right. So the shear force at point E. All right. The shear force at point E, since we know up to point D, so it's going to be minus 0.338. All right. And the shear force at point E is going downward, so it's going to be minus 0.015. minus 0.707. So if we subtract this, what do we have? Minus 1.045 kilonewton. All right. So the shear force at point A now. The shear force at point A, of course, is going to be equal to what? 0. All right. So that is what we have. Now, the next thing we are going to do is to go for the bending moment calculation. All right. All right. So the bending moment at point what? At point B, of course, we know that this is a simple supported beam, and the bending moment at the at the end of a simple supported beam is equals to what? 0. All right. So now the next one is point C. So the bending moment at point C will be equals to, all right, if we stand at point C, we have this force and this distance. So it's going to be RB multiplied by 2. Now our RB is 0.765 multiplied by 2. So this will be equals to what? 1.53 kilonewton meter. All right. So the next one is bending moment at point D. All right. So if we stand at point D, we're going to have this force multiplied by the total distance here, and this force multiplied by the total distance. So RB, which is 0.765 multiplied by, what is the distance there? That is 3.5 minus 0.75 multiplied by what? Multiplied by 1.5. All right. So if we do the math, what are we going to have? 1.5. So we are going to have 1.5. Okay, 1.55 kilonewton meter. All right. So the bending moment at point E now. All right. So the bending moment at point E. We stand at point E from this point to this point, from this point to this point, from this point to this point. So RB multiplied by total distance, yeah, that is 35. So it's going to be 0.765 multiplied by 5. All right. Then minus 0.75 multiplied by total distance there from C to E, that is 3. All right. And minus 0.353 multiplied by from D to E, that is 1.5. All right. So if we do the math, what are we going to have? 1.045 kilonewton meter. All right. So the last but not the least, the bending moment at point A is going to be equals to what? 0. All right. So now the next one is our axial force calculation. All right. So we have axial force at point C, at point D, and at point what? E. So axial force at point C. All right, at point C, we only have just one axial force, which is this one going in this direction. So we are going to take our direction. So let's take this direction to be positive. So this direction is positive. So it's going to be what? 1.3. All right. So the axial force at point D, axial force at point D will be equals to, if you sum, the two of them, they are going in the same direction. If you add the two of them together, we are going to have what? 1.653. So we are going to have 1.653. At least if we sum these two together. All right. So now the axial force at point E now. all right, will be equals to what? If we sum these two, you know, if we start at point E, the axial force you'll be seeing is 3 now. This, and this, but this one is going like this, while this other two is coming like so. If we sum this and this, subtract it from this, so we are going to have 1.653 minus, that is the sum of that, so minus 0.707. So it's going to give us what? 0.946. All right, so that is going to be our axial force calculation. So now we are going to draw our shear force, our bending moment, and our axial force calculation. Stay tuned. Start with the shear force now. The shear force diagram. So the shear force at point B is 0.765. All right, and which is the highest number. So let's take this point to be our 765. All right, so we are going to join this point to this point here. All right, and between B and C we don't have any load, so we are going to have a constant line here. All right, so now at point C we have our shear force to be what? 0.15. So 0.15. Let's make it to be somewhere around here. All right, so now between point C and D we don't have any load, so we are going to have a constant line here. All right, so now at point D we have our shear force at point D to be what? Minus 0.338. So we are going to minus 0.338. So let's make this point to be that. All right. All right, so that's it. So now, and between D and E we don't have any load, so let's just take this point. All right, so now at point E we have our point E to be what? Minus 1.0.12. so we are still going down, so let's make this point to be our minus 1. So now between E and A we don't have any load, so we come back to this point here, then we take it back to 0. All right, so we move it back to where? 0. All right, so that's it. So this is positive, while this is what? Negative. So you can shade. All right, and you shade, it brings out the beauty of your work. All right. All right, that's it. So now let's go for our bending moment now. So the bending moment, the highest number for our bending moment is 1.55. So we have 1.55, 1.53. All right, so let's just take this point here. All right. All right, so that's it. So now at point A, at point B, we have our bending moment to be what? 0. So this is it. All right, at point C, we have our bending moment to be what? 1.53. 1.53 is not the greater, is not the highest number there. So let's just take this point. All right, so we are going to use an incliner to join these 2 points together, because every straight line on every constant line on our shear force diagram will be replaced with an inclined line on our what? On our bending moment diagram. All right, so that's it. Now from the bending moment at point D is what? 1.55. so 1.55 will be higher than this, so it's going to be somewhere around here. So we're also going to use an incliner to join these 2 points together. All right, that's it. So now the bending moment at point E now. The bending moment at point E is at what? Is at minus 0. What? Minus 0. Sorry. This is not minus, it is what? 1.045. Sorry, I was looking at this. All right, my 1.045. So 1.045 is coming down. It's coming down. So it's going to be somewhere around here. All right, somewhere around there. So we are going to join this point with this. All right, so that's it. Then we take it back to 0 at A. So we have this going back to 0 at A. All right, so that's it. So we are going to have this. All right, so that's it. So we are done with our shear force and our bending moment diagram. So the last diagram is our what? Axial diagram. All right, so our axial diagram is positive here throughout. So let's take it down. All right, so at we don't have any axial load at point B. We have our axial load at point C. So at point C, our axial load is what? 1.3, which is not the highest number there. So let's put it at this point. All right, 1.3. So, and if you check between these two, C and D, we don't have any axial load. So we are going to draw a constant line here. All right, so that's it. All right, so now at point D now, our load there is 1.653. So 1.653 will be somewhere around, it's going to be higher than this. So let's take this point here. All right, so 1.653. So we are going to join this line with this, which is already joined, right? All right, so now between D and E, we don't have any load again. So we'll draw a constant line here. All right. So now at point E now, we now have our load to be what? Is 0.946. So 0.946, we are going down. And this one is 1.3. So 0.9 should be somewhere around here. So let's take it somewhere around here. All right, that's it. All right, so that's it. All right, that's it. And between E and A, we don't have any other load, so we can close it at this point. All right, so that is our axial load. So then, all right, so this is positive. All right, so this is positive. So let's shade this. All right. All right. So, and in some textbook, you can see this your axial load in the negative side. It is still the same. It depends on direction. Is that clear? Depend on your direction. You know, here I said any force going towards this direction should be what? Positive. And anyone coming towards this direction is what? Negative. So in your textbook, if you see it as negative, it means that this force is taken to be what? Negative. Why this one is taken to be what? Positive. So but anyhow you are going to do it, you are still going to arrive at this same diagram, but it's just going to be what? Inverted. Exactly. So here hence the solution to this what? Calculation. So expect more numerical and stay tuned on our channel as we are prepared to give you more and more of engineering solution and mathematics and other science subjects or courses. Thank you.